All right. Welcome, everybody. My name is Brian, and I am by myself this week. And this is Civil Chat. So if you've not been to Civil Chat with us before, Civil Chat is basically me and the other Brians when they're here talking about Civil 3D and infrastructure and just having a nice conversation about the whole thing. The way this typically works is you would ask questions and I would answer them. And we're still going to do that. But last month, was requested that I spend this particular session on SubAssembly Composer. And so that is what we're going to be doing this week. It's just me, so hopefully I'll have to monitor the chat, monitor the question Q&A. Hopefully somebody, Brian or Brian, will come in, but I haven't seen either one of them yet. But we'll make do. So SubAssembly Composer, if you're not familiar with it, which I'm sure most of you are, SubAssembly Composer allows you to create your own custom subassemblies for use within Civil 3D when the out-of-the-box stuff doesn't work or is just too difficult to try to get it to work. And so we can create our own subassemblies. And this session, we're just going to be talking about SubAssembly Composer. Now, feel free to keep asking questions. I will do my best to monitor them. Hopefully we don't have the same issues we had last month with somebody putting inappropriate things in the chat. If that happens, let me know. I'll do my best to get rid of them. But anyways, so SubAssembly Composer, where do you find it? It's a program installed on your system. So let me share my screen here. That always is helpful. All right. Ooh, flamingos, nice. Okay, so you would just go to your Windows and then just do a search for sub. Typically, this is the way I like to do it. It's in there somewhere. And I'm going to use the Autodesk SubAssembly Composer 2024. So again, what this allows you to do is allows you to create custom subassemblies for use within Civil 3D corridors. Now, the way I like to think of SubAssembly Composer is it's a combination of connect the dots and flowchart madness, right? So you're going to create a flowchart. That flowchart is then going to create the dots, and then you're going to connect them together. So I'm going to start off just super basic, really, really simple, and I'm going to create a lane. This lane is going to be 10 feet wide. It's going to have a cross slope of 2%, and it's going to be, I don't know, 4 inches thick or whatever you want it to be. And it's just going to be that. It's not going to have any parameters or anything like that. It's just going to be that shape. And again, what we're going to do is we're going to create dots, and then we're going to connect the dots, right? So over here on the left-hand side, right here in the middle is the flowchart. So this is where you're going to build everything out. And over here on the left-hand side is all the stuff that you can then add into said flowchart. And again, we're creating points that we're going to then connect together. So I'm going to come up here and I'm just going to take this point and I'm going to drag it into this area down here. And I now have my first point. Let's see. So one thing to note, if you're going to ask a question, make sure you put it in the question and answer pane. That way it doesn't get lost in the chat, because I'm having a hard time monitoring the chat. So, but if they're in the Q&A pane, there's there, and I can deal with them. So Greg, put your question up in the Q&A for me, please. Okay, so I put my first point in, and then once I have it in and I selected it, down here is how I figure out where it's going to go in the whole scheme of things. All right, so we have our point codes. We'll talk about codes later, point number, point codes. This is how I figure out where it goes. Now, what I always like to do is I always like to have my first point be at the origin. So I bring in point 1, and I just leave it set to delta X, delta Y, which, change in X, change in Y. And I just leave those left to 0, and the origin point, and it's going to go from the origin. All right, great. So I have my first point in here. Now I'm going to put another point in here. So again, I just come up here and I drag it down and I place it down below. Now, this point, where do I want this point to go? Well, I want this point to be 10 feet to the right of point 1, and I want it to go down at 2%. So instead of doing a delta X and delta Y, and I have to figure out, okay, now what is the X and what is the Y? I'm just going to change this to a slope and delta X. All right, so my slope and delta X, what is it relative to? So when I place this point, I have to do it relative from someplace else. So in this case, it's going to be relative to P1. The slope is going to be going down at 2%, and the X is going to be 10 feet. So it's going to go over to the right 10 feet, down 2%. And that's all there is to it. And if I come over here to the top right where I have my preview, I'll go ahead and fit this to the screen. You can see there it is. And what this has done, because I added this point in as a second point, it's automatically connected the dots for me. Now, I don't have to have it do that, right? That's just an option. All right, so I can come down here and I can say, hey, I don't want to add a link to that previous point if I don't want to. So if I uncheck that, you can see all I have now is the point with no link. But in this case, I do want the link, so I'm going to go ahead and add the link in again, right? Now, one thing I learned way too late in the whole subassembly composer thing is when you've got this, you can move this stuff around, and you can see it's a nice little flow chart here. And sometimes it's hard to get it just right. It's like, oh, no, too far. Oh, no, too far. Oh, that's just right. Right? You can use your arrow keys to move this stuff around. So you can, take this stuff and just use your arrow keys to adjust it around to get it lined up just the way you want. Right? I love doing that with your arrow keys. Okay, so I've now got my second link in, or my second point in. Now I need a third point. So again, I'm just going to come down here, drag a point in. The arrow's going to a spot that I really don't want it to. You can just take that and just drag it to the connection spot that you want. And then I'll use my arrows to line these up. All right, so I got my second point, my third point in. Where do I want it to go? Well, I want it to go down 4 inches below P1. So I'm going to come down here. I'm going to use delta X and delta Y. I'm going to go from point P1. My delta X is going to be 0. My delta Y is going to be a negative for 12. So I'm going to go down 4 inches. And again, because I have this add link from point on, it automatically adds the link in there. And then from here, I want to go down, same concept as L1. So once again, I'll throw another point in here, adjust it over. All right, this is going to go from point 3. This is going to be a slope and delta X. Same concept. And it throws a link in there. Now, if you notice, there is no link between 2 and 4, but I want a link there. Now, I'm not going to throw a point going from P4 up, because then I'd have 2 points there. I don't need that. I just need a link. So rather than throwing another point in, I'm simply going to drop a link in here. All right, and this link is going to go from P2 to P4. All right, and we've got the start of our lane. But then I also want to fill it in, because this is going to be a material and I'm going to add a shape to it. So I'm going to drag my shape in here. All right. And what the shape has to do is it has to have a connection. It has to have a path all the way around an area. Right. And it has to have those links. Now I could come in here and I could click on add link and then add L1 and then L2 and L3 and L4. But that's a lot of work. Instead, I'm going to come over here, hit this little green square button. Pick a point in the middle. You can see as I mouse over it, it highlights. And I now have my shape in here, and I have my first subassembly. So again, you're playing connect the dots, and then you connect the dots with lines, and then you can color in the areas that are filled in with lines with a shape. And that's the basics of it. All right. Okay, Jason, you put in the chat. I totally forgot about all of those. Which did you forget about? I'm curious. Chris's link. Perfect. Oh, okay. Chris put in a link to some sample subassemblies. Nice. Let's take a look at those real quick. There you go. Oh, nice. There you go. So yeah, there's some great subassemblies in here that you can steal and do with whatever you need to. Thanks for putting that up, Chris. I appreciate it. All right, so that's the basics. Let's expand on this a little bit. Let's take the width here, for example. I want to be able to adjust the width. I want it to be able to target something. So what we have down here in the bottom right is our parameters, right? So over here, there's tabs along the bottom. We have your packet settings. This is where you can give the subassembly a name. You can put in a description. You can put in a version, input and output parameters. So when you're working with subassemblies in your properties and you say, hey, I want to type in the slope, that would be an input parameter. If I want to be able to use this parameter for a different subassembly later on in the assembly process, that would be an output parameter. But right now, I'm going to take a look at the target parameters. So there's two things I want to do here. I want to be able to change the width and change the slope based off of a target. So in here, you can see the first line just simply says create parameter. Hey, is Brian here? Brian's here. I didn't notice you were here, Brian. Say hi, Brian. Are you muted? Make you
Sorry, I was muted. Yes, I am here.
There we go. Hey, Brian. Nice to see you.
Yeah, sorry I was late.
Yeah, no worries. We're just
One of those
having some
meetings
fun
that
with
went
subassemblies. Yeah, I hear you. Okay, so first thing I want to do is I want to target a width. So I'm going to come in here. I'm going to create a parameter. Click on create parameter. I'll give it a name rather than target parameter 1. I'll call this one lane width. Sometimes you can put spaces in, sometimes you can't. I can never remember which one it is. Now, this is not a surface, so I'm going to change it from a surface to an offset. Oops. Didn't want to create another one. And now up here, you can see here is the offset. And I can actually drag this left and right within the preview pane. And what I want is I want this lane to go out until it hits the lane width target. All right, so under P1, right, I want this to go out. All right, so slope and delta. And down here, you can see there's an offset target and an elevation target and a super elevation. Now, I'm not planning on getting into super elevation at all in this session, but I want to target the width. So my offset target, which overrides delta x, I want it to target that parameter I just put in. And there it is. And so you can see that first link is now targeting that. Right. Now, why isn't L3 doing anything? Well, because I never told it to. I just told it, hey, I want you to go out 10 feet, down at 2%, right? And so there's things we can do. I can have L3 target that lane as well if I wanted to. So I can come in here, or so that would be P4, and I could do the same thing, and I can set the target as well. And now they're both going, which is perfectly fine. There's nothing wrong with that. Right? But I'm going to show you something else you can do. Right? So this delta x, how wide do I want it to go out? How far out do I want it to go out? Well, I want it to go out the same distance as P2. So I can calculate, I can capture values from previous things in the flowchart. So I can't capture something from below it in the flowchart, but I can capture something from above it in the flowchart. Right? So if the first link I put in was L3 and then I put in L1, I wouldn't be able to use L1 as an input to L3 because it hasn't shown up in the flowchart yet. But instead of going out, say, 10 or to the target, I want to go out to whatever the x value is of P2. So I can do P2.x. Right? I want to go out the x value of P2. When I click someplace else, you can see they now match. And as I change the lane width, they both change. Now, I probably wouldn't do it this way for this one. But it's a good example of how you can use previous things as inputs for following things. All right. Now we want to do the same thing. I want to target an elevation or, maybe a feature line to control the cross slope. So I'm going to come in here. I'm going to create a new target parameter, and we'll call this one lane slope. And this is going to be an elevation offset. It's not a surface, it's just an elevation. And I don't know, we'll pull this down something like this, just down a little bit. And then P2, I'm going to override the slope by targeting the lane slope. again, you can see the P4 didn't change with it. Now I can't target the same one here because it would go to that exact same elevation, right? So if I come over here and I say, hey, I want to target the lane slope, and then they're both going to the same spot, and I don't want that. So what it's going to do is it's going to get the slope of L1 for its slope. So this will be L1 dot slope. And then as the L1 slope changes, the slope of L1 changes, the slope of L3 changes. So any questions kind of on what we've gone over so far? All right. Okay, so that's step one. Let me pull up my Word document here that has all my stuff. So one of the most important things about subassembly is the codes that go along with it, right? You know, your top and your datums, your point codes, is it you're going to use those as feature lines or as data in your surface. Each time you place in a point, you're going to have an option to put in codes, right? So the point code for this one might be crown. Now, if you notice, I'm putting in parentheses because this is text, right? So if I just put in crown, it's going to look for a variable named crown, and I don't have one. So I need to put in text that shows me that, hey, this is crown. And I think we can actually turn on the codes over here. And so you can see the code for that is crown. All right, and then maybe for here, I could put in ETW for edge of travel way, and et cetera. And this links as well, right? So this link, if I scroll down, you can see down here, this is the automatically created link. I can add my codes in here. So this would be top. Now, if you want to put in multiple, right? So maybe this is the top and the pavement. You just separate them with commas. I believe it's commas. Yep, so that's a comma. And now it has two codes. It has the top code and the pave code. And your codes are important, right? If you've ever done any modeling with corridors, you know they're pretty damn important. So make sure you put your codes in there. But yeah. Now, this I don't like. This gets annoying. Oh, you know what? I forgot something. I need to add something in the middle there. I got to move these things all around. So what I'm going to do is I'm going to show you an easier way of dealing with this. I just want to go from 1 to the 1 to 1 to 1 to 1. There's no branching. There's no decisions. It's just one right after the other. And so what I like to do is I like to come in here and I like to put in what's known as a sequence. So I like to put in my first point right there at the top, right? Delta X, delta Y, perfect. And then I will add in a sequence. So over here under workflow, you can see we now have a sequence. So I'm going to grab my sequence and throw it underneath there. And I'll go ahead and adjust that up a little bit. And the nice thing about a sequence is it's just a flow chart, but it's just one direct line. So I'm going to double click to go in here. And now I can just drag and drop things in here. So I can drag another point in here. All right, this is going to go from point P1. It's going to have a slope and delta Y. I'm sorry, slope and delta X. And I'm just going to do this really pretty basic. Right, add a link to from the point, and there it is. And then I can just continue to add additional ones underneath this. There's no dragging them. There's no arrows. You just bring them in. I think I put too many in here, right? All right, so P3 would be delta X and delta Y from point 1, the delta Y of a minus 4/12, et cetera, et cetera, et cetera, et cetera, et cetera. But the nice thing about this is it's really easy. As oh, I forgot something. I can just grab something and add it in the middle. I don't have to worry about reconnecting arrows or anything like that. The only drawback to this is it does take up a little bit more space. The flow chart is a little bit more compact. So Lisa, where did I get the sequence window? I just pulled it over from over here underneath the workflow. And you can put a sequence inside of a sequence, and you can put a flow chart inside of a sequence. So if I then needed to go in and do a decision later on, which we'll talk about later, I can drag in a flow chart under there. And when I double click to go into flow chart, This is an embedded flowchart inside of the sequence, right? These will help you a ton keeping things organized. I really love flowcharts, the sequence option here. And then if you need to go back up, you can see where you are in this nested hierarchy. So I can just go back up to the sequence, and then I can go back up to the primary flowchart altogether. So if you aren't using sequences, I'd highly recommend you take a look at them. You can also rename a sequence. So if I double click on the name, I can say, hey, this is the lane. And then my next sequence might be so after that, after it gets done doing the lane, right, my next sequence might be the shoulder. Right, or whatever you want to put in there. So yeah, I like sequences. Talked about targets, we talked about sequences, codes, created a basic lane. Let's talk about some of the more complex stuff that we can do. Let's see, I'm gonna move that. Let's talk about inputs and outputs. So I want to be able to input the width of this lane. I also want to be able to input the depth of the lane, and I want to be able to input the slope of the lane. All right, so I want to be able to input those. So again, over here under the target parameters, I would just come down to the input output parameters. All right, so again, these are the values that you're going to see in the properties when you're putting in your subassembly. If you notice, there's already an input in here, so I'm going to go ahead and of a side. So I'm going to set that default value to a right because this is going to be working on the right-hand side. And then I can just come in here and create my parameters. So this parameter here, we'll call it the width. This one will be the thickness. And this one will be the slope. So I've created the parameters. Now I need to tell Civil 3D what the parameters represent, what kind of values they are. And that's where this type column comes into play, right? So the width is going to be just a double. If you're not familiar with computer coding stuff, a double is just basically a number. It's a real number. It's a rational number, so no irrational numbers, right? The computers have a hard time like remembering rational numbers. So it's just a number. It's 1, it's 3.7, it's 8.76, it's 2000, right? -30, right? So an integer has to be a whole number, a string is text, all right? My thickness is also going to be a double, and then my slope is going to be a grade. So grade is percentage, slopes are rise over run. And so you make sure you set those correctly. And now as you're going through doing your lane, so I'm gonna get rid of my shoulder here. And I think let me get rid of all of this stuff in here. All right, so I've got this point here. And as I come down here, right, I have the slope. Well, let's start off with the width, right? So I don't want this to be 10. I want it to be whatever the width parameter is. So I just put in width. So let me go ahead and set this to a value. Let's see, we'll set that to 5. My thickness will set to 0.333, and my slope will set to a -2. We'll set it to something -10, just so it's different. All right, so my delta x, instead of 10, will be width. And just type it in. Now, if it has to be exact. I don't know if it's case sensitive or not. It'll let you know if it's not, right? And so this is this. And now when I click in the next cell, you can see that it has changed. And then I can do the same thing with the slope. Instead of putting in a number, I want to put in this value here, -10%. And now as I change these values here, like, so for example, I'm working in Civil 3D and I change the properties of the subassembly, right? We'll change that to a -2. You can see in the preview, it changes. And I can still override the width and the slope with those target parameters, right? I can still do that. There's nothing wrong with that, right? And then the thickness. So from P1, I want to go down. So I'll throw another point under here, right? This is going to go from P1. It's going to be delta x, delta y. X is 0. And the delta y, I want it to go down 0.333 feet, or whatever value this is. Right now, when somebody is inputting this, they might think, ooh, the thickness, I want it to be 0.333 feet. But somebody else might look at this and it's like, ooh, I want this to go down 0.333 feet. So they might put in a negative 0.3333. Somebody might put in a positive, somebody might put in a negative, but you know that you always want it to go down. Whether they input a positive or a negative value, you always want it to go down. And so in situations like that, where you know it always has to go this direction, you can't assume the user is necessarily going to put that value in. So for the delta y, we're going to do a little bit of math here, right? So you've got all sorts of math things, and I'll show you where you can find this later. But basically what I want to do is I want to do the absolute value of this, but a negative absolute value of it, right? So I'm going to put in a negative, and then I'm going to do the math. So math. Right? Now, what math do you want to do? Well, I want to do an absolute value. So I'm going to put a dot ABS, a dot ABS for absolute. And then in parentheses, I'm going to get the absolute value of what value? So I'll do my open parentheses, and that's going to be the thickness. And I put my close parentheses, and you can tell it's a valued expression because the little red exclamation point thing goes away. Right now, it is not valid because I don't have that closing parentheses. I close it off, and it now has that there. And then when I click outside of it, you can see it is going down this value. So if I were to put in a -5, it goes down 5 feet. I shouldn't have put in 5. Probably should have done like -0.5, what I meant to put in. Or if I put in a positive 0.5, it still goes down because it's taking the negative absolute value of it. So it's just something to keep in mind. And so that's how you can put input parameters. You can also do output parameters if you're going to use the value in a downstream subassembly later on. You can do an output parameter as well. Any questions so far on what we've covered? Is this making sense? I always like to think of this as a puzzle. It's like, okay, what do I have to do to create this thing? All right, so let's see. Let's take a look at these. So your basic ones are going to be points, links, and shapes. Those are the primary ones. Now let's say let's see. Let me pull up CAD here just so I can sketch something. So here is kind of my assembly point, right? And what I need to do is I need to go down at say 10%, and I'm going to go up, over, and then down to wherever that line is. Now this width can vary. So I can't just say, hey, I want to go down a certain distance because it's going to change as we move further in and out. Right? So, you know, if this stretches out like this, you can see it's no longer connecting here. So I want this to, you know, tie into that, like that. And so how do we do something like this? Well, we have auxiliary stuff. All right, so if I come back over here to subassembly composer, so let's go ahead and do this. Let's see, let me just go create a new one here. All right, go ahead and throw in my starting point, throw in my sequence. And yes, I know I should line these up a little bit better just to make it nice and neat. There we go. All right, and in here, I'm going to go up, over, and then down to something. So I'm going to throw a point in here. All right, this is going to go from point P1, and we'll just say, hey, I want to go over 5 and up 5. All right, throw that link in there. And then I'm going to throw another point in. This is going to go over 5 from that previous point. Throw that link in. And now I want to go down to wherever that line would extend to, where those two would intersect. And so what I have to do is I have to like draw in a fake line, so to speak, that gives me something that I can reference. And that's where these auxiliary stuff comes into play. All right, so I'm going to throw in an auxiliary point into this mess. All right, this is going to go from origin or P1. It doesn't matter in this case. And this is going to be a slope and delta x. All right, my slope, I want to go down at 2%. And the delta x really doesn't matter. All right, it just doesn't matter. It could be 1 feet, it could be 5,000 feet, doesn't matter. I just need to make sure that it's got that line. So if I toggle on that link, you can see this line is what I want to eventually tie into. All right, so I'm going to create that auxiliary point and the auxiliary link. And now I'm going to come down from here and I'm going to go down at 1 to 1 until I hit this line. And that's where we got some of these other advanced geometry options. So this is going to be an intersection point. So I'm going to throw an intersection point in here. This is going to go from P3. Right, so the type is going to be intersection 2 links. No, I don't have 2 links that I want to intersect. So I want to do a point and slope. Right, what point do I want to go from? I want to go from point P3. And what link do I want to use? I want to use AL1. And you'll notice there's no solution here. And the reason there's no solution is if I came down here at, well, again, the slope is 0. So let's set that to minus 100%. I don't know why it does that. It likes to add extra zeros in there for me. All right. If I come down here at 100% or 1 to 1, it's not going to hit this line. And so what I need to do is I need to extend the slope. When I toggle on extend slope, it still doesn't happen. Maybe I need to reverse the slope. See, it's coming down this way. Let's throw a link on there. See what's going on. Oh, there's no option for option. Oh, I didn't toggle on extend link. I did extend slope. That's what I did. And I don't want it to reverse. And you can see it's coming out to here now. And then I can throw a link in here. And that will go from P3 to P4. Right. And so I'm using this auxiliary link to help me figure out where this real stuff needs to go. And this auxiliary stuff does not show up in Civil 3D. It's just here to help you figure out stuff. And if I were to come into this here and say, hey, instead of going down at 2%, and I could use a parameter for this, an input parameter. Say I want to go down at 10%. 1,000%, 10%. You can see this point moves down with it. And if I change that to 5%, again, you can see that point then changes as well. All right. So that's an example of where you can use auxiliary links, auxiliary points, and things like that. Any questions on this so far? See, we've got a couple of questions, but they don't look like they're subassembly composer related. So I'm going to hold off on those just now. Okay. Let's talk about surfaces now. So let's talk about daylighting. So I'm going to do basically the same concept here. The primary difference is instead of going to this link, I want to actually tie into a surface. So I'm going to go up, over, and down. And this point is actually going to be on a surface. And this point is going to be on a surface. And basically, I'm just putting a berm on top of an existing surface, so to speak, right? So let me go ahead and get rid of that. We'll get rid of that, and we'll get rid of that. And then from here, I simply want to daylight down to the right to a surface. So the first thing I have to do is put that in as a target parameter. So under my target parameters, I will create a surface, and I'm going to call this EG, right? And again, I can move this up and down just like I can with the other ones. Excuse me. And then we'll throw that point in there. All right, this is going to go from P3, throw that link in there. And this is going to be a slope to surface. Right? And again, I could put in the slope value if I wanted to, right? If you notice, we got some warnings going on here. What's going on? Well, I haven't told it what surface to target yet. So we'll go ahead and set that target. And you see it's going way off because right now my slope is a -2%. We'll set that to a -100%. All right, and there it is. All right. And you know, maybe over here we're gonna just do a vertical straight down to the surface. So again, we have options over here. So let's see, I'm gonna put in a point that goes from P1. And this is going to be a delta X on surface. All right, so I just want to go straight down or up to the surface from this spot. So this will be delta X on surface. My surface target is going to be the existing ground. My offset target, my delta X is going to be 0, and we'll throw a link in there. And so I've got this shape. And now what I want to do is from here, from P5 to P4, I want there to be a link to follow the surface because I need to be able to hatch this or calculate volumes on this or something like that. And so what we have is we have the ability to put in a surface link. Now this is going to be a single link that follows the surface. And so it's going to go up and down as the surface goes up and down. But in the preview, our existing ground is just flat. And so it's just going to look flat. But once you actually get into Civil 3D, it works really well. All right, so I have a surface link here. And again, I'm just going to drag this into my sequence. And there it is. Now, where do we want this surface link to start? Well, first of all, I have to do is I have to give it a surface to follow. So this is going to follow the existing ground. And then where do we want it to start and where do we want it to end? Now, I can't just say, hey, I wanted to start, and this is looking for an X value. So I want this to start wherever P5 is, and I want it to end wherever P4 is. So I'm going to come in here and I'm going to say, hey, my start is going to be the X value of P5. So this will be P5 dot X. So that's the X value of P5. And then for P4, come down here, and this was going to be the P4 dot X. And there it is. And so now you can see it puts that link in there for me. And now all I have to do is throw a shape in here. So I'm going to come in, drag in my shape, right? I don't want to have to pick all these links, so I'm just going to hit the little button here to pick a point in the middle. And what you'll notice is it's not working. Well, why isn't it working? This is a closed figure, but why isn't it working? The reason it's not working is because it's not mathematically connected. It might be physically connected, but it's not mathematically connected. So when we created this surface link, it created the points P6 and P7. Those happen to be at the exact same location as P4 and P5, but there's not the same point. So what this is saying is I've got a link that goes from P5 to P1 to P2 to P3 to P4, and then I have a link that goes from P6 to P7. There's gaps there. And what we have to do is we have to fill in those gaps with a zero length link. And this is where the sequence comes in really handy. I don't have to worry about those silly little arrows. All I have to do is throw in a couple of links. All right, so I'll throw in a link here. I'll throw in another one. I'm getting warnings here because I still haven't told it where to go from. So this is going to go from, what's that, P5 to P6, P5 to P6. This one over here is going to go from P4 to P7. And now I've closed up. You can think of it like a polyline. This is now a closed polyline. It just happens to have zero length segments, right? So now when I put in my shape, I should be able to, why is this not working? All right, let me get rid of the shape. Let me try dragging this in again. There it goes. And now I can fill in that shape and it's working because it's now a closed polyline. It's not that open polyline. Again, it's just an analogy. All right. So let's talk a little bit about the math. Where do you find all the different ways you can do math in Subassembly Composer? Well, you go to the help. All right, so I'm in Subassembly Composer. I hit F1. It brings up the help for me. Go ahead and close out of those. And in here, we have the entering or calculating property data. So go to that. And then we have expressions. So under expressions, and then I can go into functions and operators. And here's the MSDN mathclass.net framework. So when I click on that, it'll take me to this website. So this is a Microsoft website. And in here is all sorts of different, as I scroll down a little bit further, these methods, this is what you're looking for, right? So you can see there's that absolute value. That's the one I used earlier. And before any of these, you have to tell it that, hey, you're doing math. All right, so over here on the left, you put in math dot, then whatever value you want, and then you put in the information you want, right? So if you're trying to take the sine of an angle, right, it'd be math dot sine. Right, so if I found down here, there should be sine, and that will give you the resultant sine of that number. Right? And then you can use that in your subassembly to create whatever it is you need. So this is where you can find out what the different values are for math. Let's see, what else do I want to talk about? Variables. All right. Sometimes you're going to do the same math over and over and over and over and over and over and over again. Or, you know, and so rather than, you know, coming in and saying, hey, I want to do, you know, like that, the slope value that we were talking about earlier. So I have an input target parameter of the side slope. We'll do side slopes, right? And we'll set that to slope. And so this is going to be the slope for L1, the L1 and L3 here. But I only want them to put in one value, and then I want to go up here, and then I want to go down here. And maybe I have to do this lots of different times. So rather than constantly doing the math.abs. You know, slope, and then the minus math.abs parentheses slope, I can create variables for these. So I'm going to come back up here above my flow chart, and I'm going to throw in another sequence. And we'll go ahead and connect these. Connect that to there, connect that to there. All right, so this sequence here will be the berm, and this sequence here will be the variables. Go into the variables, and what I'm going to do is I'm going to define the variables. So I'll come in here and I'll define a variable. I'll make this a little bit bigger so we can see this. The variable type, this is going to be a double, and the default value will just be 1. Sure, why not? Doesn't really need to be anything. And then I have to give it a name. All right, so this is going to be the inner slope. And then I'll do the same thing. I'll define a variable for the outer slope. Variable type, again, will be a double, or actually this is going to be a, oh, and then this will be 1 as well. All right. So I've defined them, and you probably could just go ahead and under the default value, put in the expression if you wanted to. But let's say, you know, these things change as you're going through your subassembly. You can now use the set variable value to set those values. Right? And this can be done, you know, much later on in the subassembly. I'm just using this as an example now. So I'm going to come in here and I'm going to set a variable value. The name, I'm going to do the inner slope, right? So that's this slope here, and it is going to be math dot absolute value of side slopes. And then I'm going to set a variable value again. All right, this will be the outer slopes, and this will be a minus math dot absolute value of side slopes. And now, if I come back up to the berm for L1, instead of a slope, I'm sorry, this should probably be a slope and delta x. So my delta x will be 5, and my slope will be inner slope. what I called it? I can't remember what I called it. Yeah, inner slope and outer slope. Ah, there we go. So that should be 1, 2, 1. There we go. And then likewise, my P4, this slope will be a outer slope. And now if I come in and say, you know what, well, maybe I'll do this at a 2 to 1. You can see they both change. So by changing the one variable, I changed both of them, and I don't have to do the math every time throughout the subassembly that I need to do this. All right, so I had one person reach out to me since our last session with a question about how to do a certain task. All right, so let me go ahead and pull this up here. And so what they have is they have this tailings dam, and it has benches in it. And what they're going to do is they're going to reclaim this. And so they're going to take a bulldozer from the top, drive down it. They're going to cut this out, fill it in here, cut this out, fill it down here, et cetera, all the way down to the bottom. The problem is how do we know when to stop? So we want to start here and go down until we hit the last surface, because we're going to fall through this surface multiple times. And depending upon the orientation and the exact grades and everything, this could be fairly complex. So how are we going to do this? So let me go ahead and switch over to Civil 3D so I can sketch this out. All right, so we're starting here, let's say, and I eventually want to go down at, say, 1 to 1, something like this. But my existing ground surface is going to be coming in, you know, maybe doing something like this. Now, who knows? And what I want is I want this to continue on down until the very last time it hits the surface. So I don't want to daylight it here. I don't want to daylight here. I don't want to daylight here, 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 here. Now, Civil 3D does have that multiple intercept sub daylight, but you have to tell it how many times it's going to intersect, right? And in this cross section, it's what, 1, 2, 3, 4, 5, 6, 7 times. But in another cross section, you know, this might be here like this, so it's only 5 times. So we can't just put in a number to figure this out. We got to do something else. And so what we're going to do is we're going to take this, and remember that auxiliary link thing that we were talking about. We're going to daylight this at, we're going to take an auxiliary link and put it way out here, someplace way beyond where we think it will ever daylight. And then from here, we're going to go back to the original spot with the daylight. Right? And in essence, what this will look like is that. Right? So we're going to go from here, and we're just going to go down at 1 to 1 to this point here. And then from here, we're going to daylight back to this point here. And we're not going to do it with a real daylight. We're going to do it with an auxiliary link. And then from here, we just simply put in a link to the origin. All right, so let's see how that looks. Come back over here to Subassembly Composer. I create a new one here. All right, go ahead and throw in my point. All right, so this will be my origin. And now I want to go way out. So let me go ahead and throw in my sequence because I like sequences. And I'm going to throw in an auxiliary point. So I throw an auxiliary point in here. I need a target. So let me go ahead and create my surface. This will be EG, and it's going to be down something like this. All right, now this surface could be varying, but in the preview, it's only going to show me the 1. All right, and my angle, my auxiliary point will be a slope and delta x. My slope is going to be whatever my desired slope is. Again, this could be an input parameter, so I'm just going to set this to minus 100%. So it's going down steep. And my delta x is going to be huge, so 1,000. All right, so we're going out 1,000 feet, which I know is way beyond what I need, right? 100 feet might be way behind. 10,000, you might need to go out a couple miles, who knows, right? But it's beyond whatever I was. And then from this point, I'm going to come back towards the origin until I hit the surface. All right, so I'm going to throw another point in here. right? This is going to go from that auxiliary point. Sorry, this shouldn't be a point. Yeah, I could do that as a point. Right? It's going to go from that auxiliary point, and it's going to be a slope to surface. Right? I'll put in that same daylight surface. All right, so this one's actually going to be the opposite. So this is going to be 100%. All right, and it's going to target the existing ground. And there it is. So we go all the way out, way beyond, and then we simply come back, and then we just throw in a link. So this link is going to go from P1, P2. And there it is. It doesn't matter how many times it crosses, it's always going to grab the very last one, assuming that this auxiliary point goes out beyond the very last one. Now, you might be in a situation, right? So if I come back here, all right, let's go ahead and move that back, where, this surface continues on, something like this, and then it just like dives down. And I don't want it to go beyond this point here. So what do you do in that case? Well, you would draw a polyline where this is where I want it to go out the furthest. And then you would create a target parameter for an offset. And then in your AP1, you would overwrite the offset target to whatever that polyline is. So yeah, I'm going to go out this far, and then I'm going to come back. So not all the way out, just this far and come back. So hopefully that makes sense. All right, so once you've got a subassembly created, how do you get into Civil 3D? We're running out of time here. So let me just go ahead and open up a subassembly. Let's see. Which one do I want? Okay. So let me just switch over to Civil 3D here. So when you have your subassembly created, you're just going to go to a tool palette. Right? You're going to right click on the palette name, and you're going to import the subassemblies. And really, that's all there is to it. So you would import the subassemblies. New in some version of Civil 3D, fairly recent, I think it was 24, might have been one of the later updates in 23. There's an option to link directly to the PKT files. This is absolutely fantastic. So if the PKT files, that subassembly composer file, changes, well, then your model will change as well. You just need to rebuild your corridor, and you'll see the updates. But that's really all there is. You just browse for the PKT file, and then it gets added to your tool palette. All right, so I've got this TVA riprap one. I can then take this and insert it in. Let's just go ahead and do that. Create an assembly. Actually, we'll make that a 20 scale. There we go. And then you can add it in however you need. So this is the subassembly I created. And this is for a very specific project. So the preview doesn't look very nice, but this is the idea. And you put it in, and there it goes. And again, if it changes, your model, if you save a new version of the PKT file, then your subassembly and your corridor updates as well. Yeah, so Mike in the chat, I don't know if people are watching, just says, a blue crosshair, you madman. Like, yeah, it's been this way since I've been at GEI. This is our default. So I think what it was is they would have different colors of crosshairs based off of the version that was being used. So back in the day, when Civil 3D wasn't backwards compatible, you could very quickly tell which version you're in just by looking at the crosshairs. And yes, I do like a full size crosshair.
Helps you
Yeah,
line
Mike
things
says, go ahead, Brian.
I said it helps you lines things up from the other side. It's just one of those things. I've seen people try the light where they have a smaller one, and then also, yeah, the colorization. If you ever tried to do a white with an image behind it, you lose your crosshair every time.
Right. Well, I like crosshairs so much, I even put them in Bluebeam.
Oh,
So,
wow.
yeah.
I did not know you could do that in Bluebeam.
Yep. I don't remember where it is. I think it's in the preferences somewhere. No, not print, Control K. There we go. General, somewhere in here. Yeah, right there. Show full screen crosshairs. So if you want your crosshairs in Bluebeam, that's where you can go do it.
Hmm.
All right, so it looks like we had a couple of questions come in. I didn't really get a chance to look at them a whole lot. Somebody's asking about DotSoft or MapWorks. Are these worth the price? I don't know. I've never used any of those add-ons, so I don't know if DotSoft or MapWorks is worth the price. Somebody else says, I've inherited a Civil 3D surface, which appears to be made of a paste from a smaller surface and a whole bunch of add, delete, swap line edits. My condolences. Tool strategies for debugging how a surface is created. The
I know.
history is getting me nowhere. And that, my friend, is why I say thou shalt never use those freaking surface editing tools. I hate them with a passion.
Yep. I can't
I'm
get
so
people
sorry,
to-
Kyle.
Yeah, I've seen individuals paste multiple corridors inside of each other, and it just makes my head spin. Now, I do want to talk about Greg's add-ins and such. There are a lot of great apps that are out there that can be useful to you. The one thing I do want to caution people on is, I mean, if you're your own shop, awesome, use them. If you are part of a larger corporation, be wary about just downloading and adding, because sometimes they don't transfer across, and also licensing can become an issue. And if you have it and another person doesn't, it may not. It's kind of like having, your own personal pipes library, and you make modifications to it.
I'm a firm believer in CAD standards. That's why I have this awesome set of my own.
Yeah, exactly.
Yeah, Brian put in the chat that Kobe tools for Civil 3D is pretty great. So, and
Yeah,
again, there's a lot of them that are out there. I just haven't. I know our land development team up in Canada uses a Land Explorer, I think is what it's called. No, land something to help them with the land development stuff. Single family homes type stuff.
They got some really great things out there. I love DotSoft. Honestly, there was a lot of CAD stuff in there that was fantastic. They're not necessarily Civil 3D add-ons, but just basic AutoCAD quality of life add-ons. So, are they helpful? Depends on what you got and how often you use them. But yeah, it's just something you got to be careful
with. Yep. So it is 12:30. We're going to go ahead and call this one done. Thank you, everybody, for showing up. I will be posting a recording up on YouTube in case you missed some of it or had something else. Got distracted, missed something. It'll be up there. We'll plan on being back again on the first Tuesday of next month. That's when we typically do these. Sorry, Todd. That's when we do them. Yeah, and we'll see you then. So until then, y'all have a great day.
Yeah.
Oh, yeah, my YouTube channel. Just look for C3D Plus. That's where you can find me online. All right. So just do a search for C3D Plus. You'll find me, and we can go from there. So y'all have a great day. Take care.
And good luck, Kyle, on rearranging those surfaces. Oh my God.
Right. I'm so sorry.
I feel for him.
Oh, it's so bad. Just people don't. If you get the ears to do it, just don't.
Just don't.
Make them right. Don't fiddle with them afterwards. Anyways, take care, everybody. Bye.
Bye-bye.